Good day, class. Teacher J is here again. Last time, we discussed about the different types of weather and patterns and seasons in the Philippines. So now, we are here again to learn new things. Oops! Wait! Before that, first, let's read our learning objectives for our new topic for today. And now, here are the learning objectives for this topic. Discuss some facts about our sun. Identify and describe the different layers of the sun. Describe sunspots and explain how the sun affects our planet. And these are the learning objectives for this topic. Facts about the sun. The sun is the largest object in our solar system. It is composed of 7 layers, 3 inner layers, and 4 outer layers. The inner layers are the core, the radiative zone, and the convection zone, while the outer layers are the photosphere, the chromosphere, the transition region, and the corona. The sun is a star at the center of the solar system. It is a nearly perfect sphere of hot plasma with internal convective motion that generates a magnetic field via a dynamo process. Its diameter is about 1.39 million kilometers or 864,000 miles or 109 times that of Earth. Its mass is about 330,000 times that of Earth, with a diameter of 109 times than the size of the Earth. The sun makes a really big sphere. You could fit 1.3 million Earths inside the sun. Or you could flatten out 11,990 Earths to cover the surface of the sun. That's big, but there are some much bigger stars out there. For example, the biggest star that we know of would almost reach Saturn if it were placed inside the solar system. The sun is the solar system. We live on the planet, so we think it's an equal member of the solar system. But that couldn't be further from the truth. The reality is that the mass of the sun, it accounts for about 99.86% of the total mass of the solar system. The sun currently fuses about 600 million tons of hydrogen into helium every second, converting 4 million tons of matter into energy every second. The sun is mostly hydrogen and helium. If you could take apart the sun and pile up its different elements, you'd find that 74% of its mass comes from hydrogen with 24% helium. The remaining 2% includes trace amounts of iron, nickel, oxygen, and all the other elements we have in the solar system. In other words, the solar system is mostly made of hydrogen. The sun is the main source of heat and light. It is made up of very hot gases. These gases are so hot that they glow. The sun's surface is about 5,000 centigrade, and its temperature at the core is about 15,000 centigrade. The sun's heat and light reaches the earth through radiation. The sun is so bright that we can't even look at it. As a matter of fact, you should never look directly at the sun, because it could permanently damage your eyes. However, scientists are able to see the surface of the sun and study it with special telescopes. And now, let's talk about the layers of the sun. The first layer in the outer layer of the sun is the photosphere. This is the sun's lowest layer and the layer visible directly from Earth. It is also called the solar surface. Much of this layer is covered by granulation caused by bubbling gas in the convection layer and sunspots caused by strong magnetic fields. The sun's granulation looks grainy in the photosphere, which results in the appearance of bright cells with dark edges. The photosphere temperature varies from roughly 6,500 degrees Kelvin at the bottom to 4,000 degrees Kelvin at the top. Second outer layer is the chromosphere. This is the layer of the sun between 250 miles and 1,300 miles above the photosphere. The chromosphere has temperatures around 4,000 degrees Kelvin at the base and 8,000 degrees Kelvin at the top. As a result, in this layer and other higher layers of the sun, the temperature increases farther away from the sun, unlike in lower layers where it gets hotter nearer to the center, according to research by NASA. The third outer layer is the transition region. This layer is very thin, with a size of about 60 miles and is between the corona and the chromosphere. In the transition region, temperature rises rapidly from roughly 8,000 to 500,000 degrees Kelvin. Scientists are yet to discover the cause of this rapid rise in temperature. The fourth outer layer is the corona. Corona is the sun's outermost layer. It starts at roughly 1,300 miles above the photosphere and has no upper limit. Its temperature is between 500,000 degrees Kelvin to 1,000,000 degrees Kelvin. The corona cannot be seen with the naked eye, but can be viewed using a coronagraph telescope during a total solar eclipse. And the last outer layer is the coronal holes. These are areas where the sun's corona is colder, hence darker, and has lower density plasma than average because there is lower energy and gas levels. Corona holes part of the sun's corona and are constantly changing and reshaping because the corona is not uniform. And here are the inner layers of the sun. The first one is the core. The core is the sun's middle region where energy is generated by thermonuclear reactions, which create extreme temperatures of about 15 million degrees Celsius. These nuclear reactions used hydrogen to produce helium. As a result, energy is released, which leaves the sun's surface as light and heat, which we receive on Earth, and this is according to NASA studies. The core extends to roughly a quarter of the way from the sun's center. The second inner layer is the radiative zone. This zone is between the core and the convective zone and is roughly 70% of the sun's radius. Energy produced through nuclear fusion in the core moves steadily outwards as electromagnetic radiation, taking over 170,000 years to pass through the radiative zone. In this zone, energy is carried outwards through radiation by photon carriers through a process where it bounces many times in zigzagging paths. The last inner layer is the convection zone. This layer of the sun is above the radiative zone and is the outermost layer of the sun's interior. It stretches from as deep as around 200,000 kilometers right up to the visible surface. The temperature at the bottom of the convection zone is about 2 million degrees Celsius. Energy moves towards the sun's surface through convection currents of heated and cooled gas. This happens when the density of the radiative zone gets very low, and the energy from the core in light form is converted to heat. Heat from the edge of the radiative zones rises until it cools enough to sink back down. This pattern of heated material rising and cooling occurs in the convection zone cells. The sunspots. Sunspots are dark, cooler areas that appear on the surface of the sun called photosphere. They are caused by strong magnetic activity within the sun. Sunspots are not permanent and they can move slowly across the surface of sun, changing size as they move. The appearance of sunspots follows the solar cycle of 11 years. Every 11 years, there will be a period of increased sunspot activity. Sunspots vary in size from as small as 10,000 miles across to as large as 100,000 miles across. The sun plays an important role on Earth. Nothing is more important to us on Earth than the sun. Without the sun's heat and light, the Earth would be a lifeless ball of ice-coated rock. The sun warms our seas, steers our atmosphere, generates our weather patterns, and gives energy to the growing green plants that provides the food and oxygen for life on Earth. But despite of this, the sun is heating up and will kill all life on Earth. It feels like the sun has been around forever, unchanging, but that's not true. The sun is actually slowly heating up. It's becoming 10% more luminous every billion years. In fact, within just a billion years, the heat from the sun will be so intense that liquid water won't exist on the surface of the Earth. Life on Earth as we know it will be gone forever. Bacteria might still live on underground, but the surface of the Earth will be scorched and uninhabited. It will take another 7 billion years for the sun to reach its red giant phase before it actually expands to the point that it engulfs the Earth and destroys the entire planet. Here are some good and bad effects of the heat and light of the sun on the Earth. Good effects of heat and light of the sun on the Earth. Light from the sun provides you with vitamin D. It is often referred to as the sun vitamin. Vitamin D is involved in maintaining a healthy body. One way you can get this vitamin is exposure to the ultraviolet light from the sun. Second good effects is light from the sun improves sleep quality. Exposure to sunlight impacts how much melatonin your body produces. Melatonin is the chemical that tells your brain when it is time to sleep. With a lack of sunlight, your body produces far more melatonin than is needed. Hence, you feel tired and ready to sleep more often and earlier. Almost all living things rely on the steady heat and light of the sun. We receive just the right amount of heat from the sun so living things survive. The sunlight brightens the earth and helps us see the things in our surroundings. Plants can undergo the process of food making called photosynthesis with the aid of the sunlight. Aside from that, the sun's heat warms the earth and affects the changes in temperature of the earth's surface, causing the changes in the weather conditions. Without the sun, Earth's land, water, and air would all be frozen, solid. Life on Earth would cease to exist. That's because almost all living things rely on the steady light and heat of the sun. The sun's heat makes liquid water on our planet possible, and all life that we know of, from bacteria to elephants, needs liquid water to survive. Here are some bad effects of heat and light of the sun on the earth. The first one is the water vapor. Water vapor is the most abundant greenhouse gas. It does not stay in the atmosphere for very long, but plays a key role in our climate and its variability and change. Water vapor is also an effective greenhouse gas, as it does absorbs long-wave radiation and radiates it back to the surface, thus contributing to warming. However, water vapor does not control the Earth's temperature, but is instead controlled by the temperature. The second is the sun's UV light, or ultraviolet light. Aside from its heat and visible light, the sun also shines in ultraviolet light. Ozone in Earth's upper atmosphere blocks much of the UV. However, pollution can weaken the ozone shield. Then, the sun's UV light can harm living things on the ground and in the top layers of the oceans. Even when the ozone shield is strong, the UV that gets through help form smog from car exhaust and other pollution. Effects of the excessive UV radiation can lead to sunburn, skin cancer, and eye damage. Third one is the ozone. Ozone in the lower part of the atmosphere acts as a greenhouse gas and is a major pollutant. Ozone, or O3, is a highly reactive gas composed of 3 oxygen atoms. It is both a natural and a man-made product that occurs in the Earth's upper atmosphere. Higher up, in the stratosphere, the ozone layer absorbs solar ultraviolet radiation and affects how much of the sun's heat is radiated back into space. The ozone layer shields us from the harmful effects of excessive UV radiation, which can lead to sunburn, skin cancer, and eye damage. The last one is heat exhaustion. Too much sunshine can cause excessive sweating. Sweating leads to the loss of water and essential salts in the body. This may result in heat exhaustion. If heat exhaustion is left untreated, it can lead to heat stroke. Heat stroke is the most serious heat-related illness and can be life-threatening. Heat stroke causes the temperature of the body to rise quickly. And that's it. I hope you learned a lot about our topic for today. So goodbye class, and have a good day.